Now let's understand rate of reaction. So this is a very common word which we use throughout the entire chapter. We are familiar with processes in which something changes with time, isn't it? So rate is usually expressed as the ratio of amount of change in some quantity to the time required to produce that change. Mathematically we can write like this. Rate is equal to change in some quantity upon time taken for that change. And this one you can write like this, delta x upon delta t. And what is this delta x? Delta x is nothing but equal to the difference between the final state value and the initial state value. Means the change in that quantity is equal to delta x. Then what is this delta t? And delta t is nothing but equal to the time taken for that particular change. That is of the time taken for the particular change of delta x. Let me give an example to make it more clear. In order to calculate the average speed of a car, what we need to do? First we need to find out the distance covered by the car in a given time. Isn't it? Suppose if I say that a car covers a distance of 250 kilometers in 5 hours, how you will get the average speed? It is nothing but equal to the change in the distance 250 upon the time taken to cover the distance 5. So 250 upon 5, that is 50 kilometers per hour. Isn't it? And here this example indicates that the car has been driven with uniform rate of 50 kilometers per hour. Now tell me, is it actually possible like that? Can you drive a car with the same average speed of 50 kilometers per hour throughout the entire journey? Definitely no. Why? Because sometimes you need to go faster and sometimes you need to go slower depending upon the road conditions as well as the traffic also. Isn't it? Understand this by seeing this animation. See, watch the speedometer here, how it is changing. So it is coming with some speed of 100 kilometers. It came to 40 here, slightly increased to 60. Again it is increased to 100 and 120. So the car has been driven with uniform rate, but actually it has been driven sometimes faster and sometimes slower depending upon the conditions of the road. Thus the overall rate is an average rate, isn't it? And the rate at which the car was moving at any instant, that is the instantaneous rate that is changing from time to time. So for a moment I will leave about the term instantaneous rate. We will discuss that one later on. So that is the meaning of the average speed or the average rate. So what is the conclusion here? The rate measured over a long time interval, that is called as the average rate, and the rate measured for an infinitesimally small time interval, means very minute time interval, that is called as the instantaneous rate. Just as the speed of the car is expressed in terms of distance travelled per unit time, the speed or the rate of the chemical reaction is expressed in terms of the change in concentration of the reactant or the product with time. Let's understand the meaning of average rate in terms of chemical reactions. In a chemical change, we know that reactants are converted into products. Now tell me what happens when the reaction is progressing. Now tell me what happens when the reaction is in progress. Yes, as the chemical reaction proceeds, the reactants are consumed, means the reactants are involved in the chemical process, and simultaneously products are formed, isn't it? So in another way, we can say that when the reaction is in progress, as the reactants are consumed, the concentration of the reactants decreases and the concentration of the products increases. So when we draw a graph between concentration and time, we get the graph like this. So in this one is for the reactant and one is for the product. Now identify which among them is for reactant and which is for the product. What we are saying here, we are saying that along with the time the concentration of the reactant is decreasing, isn't it? So along with the time the concentration of the reactant is decreasing. So this will be the variation of concentration of reactant with time, and this will be the variation of the concentration of product with time, where concentration of the product is increasing along with the time. So it means that, or we can say that, both the concentration of the reactant is changing and the concentration of the product is also changing along with the time. So we can define the rate of reaction as the change in the concentration of any one of the reactant or product per unit time. Here we are talking about the average rate, that is defined as the change in concentration of any one of the reactant or product with time. And mathematically we can write like this: average rate is equal to change of concentration of one of the reactants or products divided by time taken for the change. Let me take an example and explain this. So consider a hypothetical reaction where A is converted into B. Now the average rate of reaction may be expressed either in terms of decrease in concentration of A or in terms of increase in concentration of B. So I can write like this: average rate of reaction, this is equal to decrease in concentration of A upon time taken for that change, or in terms of products we can write like this: average rate of reaction is equal to increase in concentration of B divided by the time taken for that change. So here we express the concentration of the reactants or products as number of moles per liter. So as the rate of decrease or increase in the concentration of reactants or products may also be expressed in terms of change in their concentration during the time interval delta t. We can write like this: average rate of reaction is equal to minus delta A upon delta t. And what is this delta A? Delta A is the change in the concentration of A in that particular time interval delta t. Or we can also write it as average rate of reaction equal to plus delta B upon delta t. And what is this delta B? Delta B is again the change in concentration of B in the small time interval of delta t. So one very important thing here to notice is, in front of A we are writing a negative sign, and in front of B we are writing a positive sign. First forget about the negative and positive sign. Let me explain the remaining part. So the average rate of reaction we are expressing in terms of change in concentration of A or change in concentration of B, and it is equal to delta A upon delta t, where delta A is the change in concentration of A in a time interval delta t, and delta B is the change in concentration of B in time interval delta t. So we are writing average rate is equal to delta B upon delta t. And what is this minus and positive sign indicate? As just mentioned, along with the time, as the concentration of the reactants decreases, the concentration of the reactants decreases, the decrease in concentration is represented by that negative sign. I repeat, the negative sign indicates the decrease in concentration of the reactant. Then what will be the case for the positive sign? Here we know that for the case of the product, along with the time, the concentration of the product increases, isn't it? And this increase in concentration of product, that is indicated by this positive sign. The positive sign in front of the product indicates that there is an increase in the concentration of product along with the time, and the negative sign in front of the reactant indicates that the concentration of the reactant is decreasing along with the time. But remember, the concentration may be positive or negative, but rate of reaction is always positive only. I repeat, concentration of the reactant or the product, it can be positive or negative, but the rate of reaction is always positive. Let us take another example. Here PCl5 is decomposed in order to give PCl3 and Cl2. So how we will write the rate of reaction for this one? It is like this. Rate of reaction is equal to minus of delta concentration of PCl5 upon delta T equal to plus delta concentration of PCl3 upon delta T, which is equal to plus delta concentration of Cl2 upon delta T. Again, as PCl5 is a reactant, we need to keep a negative sign in front of the reactant as the concentration of the reactant decreases along with the time, and we are keeping a positive sign in front of the products, both PCl3 and Cl2. But overall what we are writing is simply the change in the concentration in the particular time interval. And take this general reaction, A plus B gives rise to C plus D. How we will write the rate of reaction for this particular general reaction? It is like this. Rate of reaction is equal to minus of change in concentration of A upon delta T minus of change in concentration of B upon delta T equal to concentration of C. So here I did not write positive sign. It's compulsory to write the negative sign in front of the reactants, and it is not compulsory to write the positive sign. Whether we write positive sign or does not, it always indicates that concentration of product is increasing with the time. So delta C upon delta T, which is equal to delta D upon delta T. Is it clear? Yes.